Section 4.9 talks about Newton's method. The goal is to find this root. Given a function y equal f of x, if I pick a point x sub 0. So we pick x sub 0. Now, how do you pick x sub 0? I'll talk about that as we get to the problems and elaborate on, how to find it if it's not given. A lot of times they tell you that choose this and start with it. If not, we could pick it and start with it. Let's say it's right there. So let's say x sub 0 is right there. If I go up to the curve, that point on the curve is x sub 0, f of x sub 0. If I draw a tangent line there, the slope of this tangent line would be f prime of x sub 0. If I find an equation for that line, wouldn't that be y minus y1 equal m into x minus x1? Well, let's see. Y is f of x sub 0 minus y1, take that back, y minus y1 f of x sub 1, x sub 0 equals f prime of x sub 0, the slope of the tangent, into x minus x sub 0, right? So those normally would remain in the problem. The point is right there. And that's simply the slope of the line. Now, wherever the graph crosses the x-axis, this is x sub 0. If I call this x sub 1, wouldn't that be x sub 1, 0? Notice this x sub 1 is closer to the root than what I started with. So if I substitute in this equation 0 for y, and that happens when x equal x sub 1, and I solve for x sub 1, what would happen? I'll be looking at divide both sides by f prime of x, x1, and x sub 1 would simply be x sub 0 minus f prime of x sub 0 divided by f. Oops. Okay, everything is in terms of x sub 0. Okay, not to worry, we're going to do this again. Now, if I am to look at this x sub 1, if I go up to the function, that is x sub 1 f of x sub 1. If I draw a tangent there, that's f prime of x sub 1. If I find an equation of that line, I'm going to say y minus f of x sub 1 equals f prime of x sub 1 into x minus x sub 1. Now, if I look at where that equals 0, call that x sub 2. Y will equal 0 when this x is x sub 2. If I solve for x sub 2, I'm looking at divide by this again both sides. So I get negative f of x sub 1 divided by f prime of x sub 1 equal x sub 2 minus x sub 1. Move that to the right, to the left, and I get x sub 2 to equal x sub 1 minus f of x sub 1 divided by f prime of x sub 1. And let me do that one more time just to make sure that we see it. If I am to go ahead and choose this point, and I am to draw x sub 2 f of x sub 2. If I draw the tangent, do you see now that x sub 3, 0 is a lot closer. Initially I was there, then I got there, and I'm getting closer and closer. So when I substitute x sub 3 into that equation, well, what equation? I need to find the equation of the green line. This is f prime of x sub 2. So the equation for the line would be y minus y2 equals f prime minus into x minus x sub 2. And if I substitute in these values, if I substitute in x sub 3, then automatically I am aware that that's a 0. And if I solve for x sub 3, you know the drill by now. I'll get, divide by this both sides, negative f of x sub 2 divided by f prime of x sub 2 equal x sub 3. And if you move that over, that's x sub 2. So if I glance at this and I list them out properly, I'm saying x sub 1 equal x sub 0 minus f of x sub 0 divided by f prime of x sub 0. From the green, I'm saying x sub 2 equal, so starting with this, x sub 1 minus f of x sub 1 divided by f prime of x sub 1. And from the orange, I'm getting x3 equal x sub 2 minus f of x sub 2 divided by f prime of x sub 2. So in general, if this trend continues, x sub n plus 1 is the previous term minus f of x sub n divided by f prime of x sub n. All what I need is a starting point, and then this will all fall into place. So what they want us here, they would like us for the following exercises, write the Newton's formula whenever you want to try to figure out where the y value crosses the x-axis. So what I need f of x, f prime of x. So in this case, x sub n plus 1 will be x sub n minus f of x sub n. That's x sub n squared plus 1. That's right there. Divided by 2 times x sub n. That's what I plug in my calculator. If I use answer like we did back when we did limits, the calculator will do all of these calculations for you. Here, if I take a derivative, that's the cosine of x. So x sub n plus 1 will be x sub n minus f of x sub n. That's the sine. Again, we're going to use the answer key divided by the cosine. You could use tangent if you wish. That doesn't really matter. But that's what the formula is. Make sure you're in radian mode. And if I take a derivative here, I'll get 3x squared plus 3 times e to the x plus 3x e to the x. So in this case, I would say x sub n plus 1 will be x sub n plus that function evaluated at x sub n divided by 3 times x sub n squared plus 3 times e to the x sub n plus 3 times x sub n e to the x sub n. And again, everywhere you see x sub n, use the answer key on the calculator and that'll take care of it. And the next problem, we want to figure out where this equals 0. So we start off with, we need to know what x sub 0 is. And let me show you how to choose that. If this is the actual work, we know that if we solve this, we're going to get x to equal plus or minus square root of 10. So it says, using this method in a computer calculator, choose an initial value, find the initial x sub 0. That is not the exact root. Well, I know that square root of 9 is 3. Square root of 16 is 4. So I know that square root of 10 is between 3 and 4. I'm going to choose halfway through. I'm going to say, let's say that's 3.5. I know it's going to be more closer to 3 than it is to 4, but let's say that's the case. Now, since I'm going to have to do this over and over, and let me do the first couple of problems on the side really quick so you see it, And then, just like we did with limits, we'll use the calculator, use the answer key, and that'll do the trick. Let me show you how this works. The idea is that, well, I'm going to take x sub 1 is going to be x sub 0 plus, oh, I thought it was minus. It is minus. Oh, what does that say plus? That should be minus. Okay. So I'm going to apply this formula right here. X sub n plus 1 is the previous term minus f of x sub n divided by f prime of x sub n. Okay, well, let's see what we need. It's going to be x sub 0 plus minus. So I need a derivative of this. Let this be f. Let's start fresh. I'm going to let this be f of x. And I'm trying to figure out where does f of x equal 0. F prime is 2x. So the formula I have is that x sub n plus 1 is x sub n minus x sub n squared minus 10 divided by 2 times x sub n. So when I come in and I say let x sub 0 be 3 point, and you must choose an x. X sub 1 would be x sub 0, right? Minus x sub 0 squared minus 10 divided by 2 times x sub 0. And what that turns out to be 3.5 minus parentheses 3.5 squared minus 10 close parentheses, divide that parentheses 2 times 3.5. And I'll get 3.17857. I'll get 3.17857. Okay, so I put 3.5 minus 3.5 squared minus 10 divided by 2 times 3.5. Now, when I get to x sub 2, that's going to be 3.17857 minus 3.17857 squared minus 10 divided by 2 times 3.17857. Two ways of doing that. I could plug it in, and let me show you the long way. Again, we're not going to do this, but isn't that my answer right there? Isn't it stored in the answer? So can't I say pretty much it's the answer squared? Well, let's see how that plays. If I go in and I say take my answer minus parentheses my answer squared minus 10 divided by 2 times my answer, I'll get the next number, 3.1623. So I got it accurate to 1 decimal. I want it accurate to 5 decimals. That's what I'm going to ask you for on the homework. I want those accurate to 5 decimal places. So I got x2. Now, if I take x sub 3, isn't x sub 3 simply 3.1623194 minus 3.1623194 squared minus 10 divided by 2 times 3.1623194? Well, hey, but isn't that my new answer? Didn't the calculator just store that as my new answer? If I go back, now it's stored that in new answer, 3.1625 in there, and if I hit equal, it'll give me the result right away. That is 3.1622, 3.1622, 7766. So now I'm accurate to 1, 2, 3 decimals. Or I could from the very beginning just start with the initial being x sub 0, 3.5. And then x sub 1 would be, you will show me this, right? You will show me that you did 3.5 minus 3.5 squared minus 10 divided by 2 times 3.5. Or you could simply say x sub 1 is, I'll accept you writing answer minus the answer squared minus 10 divided by 2 times the answer. And watch how this works. X sub 1 will be, so if I go in there, starting fresh, assuming none of this is there, I take 3.5 as my initial, now it's stored in my answer. Clear that up and take answer minus parentheses, my answer squared minus 10 divided by 2 times the answer. It'll give me an answer of 3.17. Now the parentheses there, it repeats 857,142. 857,142. I want 5 decimals, so I'm gonna have to list a bit more. Now all what I have to do is hit the back. It stored the new 3.17857,142 in my answer, and now it gives me the next number, and that is 3.162. 3.1623 19422. Okay, now it's accurate to 1 decimal. I want it accurate to. Now I am going to ask how many iterations it took. This is 1 iteration, 2 iterations, 3 iterations, and that's why we want to start with x sub 0, so we match. Now if I go back, it's going to store that in and click equal 3.16227766. Now it's accurate to 3 decimal places. How about x sub 4? Instead of me taking this, plugging it in, it's already stored in my answer. If I hit back, it'll replace answer by that and let the calculator do the work. Click back, and now what do we have? 3.1622 7766. Now I got it accurate to 8 decimal places. I want it to 5. 1, 2, 3, 4, 5. So you could say it is 3.16278. Now if I take the square root of 10, that's the actual answer. You'll notice 3.16227. I got it accurate in 5 decimal places. And that's how the game is played. When I get to this problem, we do the same. Now this is essential for programming and certain proofs. To do this, I shall remember x sub n plus 1 is x sub n minus f of x sub n divided by f prime of x sub n, where x sub n is simply the answer I'm going to use for all of those. Well, let f equal x plus 5 the cosine of x, and I want that to equal 0. So I need an initial point. I always do. I need a derivative, that's 1 minus 5 the sine of x. So this formula just became x sub n plus 1 equal my answer minus my answer plus 5 the cosine of the answer. Make sure you are in radian mode, divided by 1 minus 5 the sine of answer. So if I just get the first guess and I start from there, I'm okay. I need to find the first guess. Let me show you how to get the first guess. If I take f of 0 is 0 plus 5 times the cosine of 0 is 5, that's 5. If I take f of pi, so I'm looking for a positive and a negative. F of pi, if I put a pi in there, that will be pi plus 5 times cosine of pi is negative 1. So isn't this less than 0 because pi is 3.14? 3.14 minus 5 is negative. Between a negative and a positive, there's a 0 for sure. So I know there's a 0 between 0 and 5. Of course, there are infinite amount of them. I just want one of them. There could be more than one. I just want one for now. One will be sufficient. 0 to pi. Well, how does that work? I take halfway. This is 0. This is 3.14. Say that's 3. I take my x sub 0, my initial guess, to be about halfway. Halfway between 0 and 3 is 1.5. So now all what I have to do is go on my calculator, make sure I am in radian mode, and I am. Take 1.5, enter. Now go and put in answer minus parentheses the answer plus 5, the cosine of that answer, divided by 1 minus 5, the sine of that answer. Make sure everything's proper. Yeah. Hit equal. That's my second x. 1.96. 1.96. 4877. 156. I want this accurate to 6 decimal places. X sub 2 will be, and how would we do this? Well, we will go back. 1.977, 1.977, pretty good. 3411, 341105. I locked in 1.9, x sub 3 would be. So I need to know how many iterations. You don't know what that means if you ever took discrete math or computer programming. 1.977, 383, 029. So this is accurate now to how many decimals? 1, 2, 3, 4. One more. If I go 4 iterations, that should do it. 1.197738 3029. So it took 4 iterations to get to where I wanted. Now, all what you should do when you take x sub 1 on that exam, show me that x sub 1 equal 1.5 minus 1.5 plus 5, the sine of 1.5. You just have to show me one of those. That's all I want. And that's a cosine, not a sine. Get it right. There. Once you write that for me, that's pretty good. That's all I want. And how about if we're doing x squared and we want the initial guess to be a 1. So we know what x squared is, right? X squared equals 0, obviously at 0. So here f of x is given. But they want us to choose, and that could happen. Well, what do you need? You need a derivative. Derivative is 2x. So x sub n plus 1 is going to be x sub n minus f of x sub n divided by f prime of x sub n. I want that formula written. You could do it in terms of answer or x sub n. I don't care. F of x is my answer squared. Oh, if I simplify that first. So that is x sub n minus x squared over 2x. Wouldn't that just simplify into x over 2? So you could tell me x sub n plus 1 is, actually you could put x sub n right there at me and you're happy, or you could write answer. I really don't care. Either way. So when they say x sub 0 is 1, all what I wanted to show me is that x sub 1 is 1 minus 1 divided by 2. That's all you have to do. Now, the calculator will take care of business. Let me see how that works really quick. This is going to be very quick. Take 1 and enter. And take my answer minus my answer divided by 2. I get a half, which is 0.5. X sub 1 is 0.5. Now, if you take x sub 1 and plug it in, 0.5 minus 0.5 divided by 2, or simply hit back, enter. I'll get 0.25. X sub 3 would be, hit back, enter. I'll get 0.125. X sub 4 would be 0.0625. This is taking a lot of iterations because of the starting point. I go back and I hit it again. 0.03125, so I got it locked to 1 decimal. Hit it back and do it again. 0.015625. Another iteration. That's 0.00. 0.00, 2 zeros. 78125. X sub 8 is going to be 0.00390.625. Now I'm going to continue here. 9th iteration is going to get me 0.00195. Again, this is moving very slow. 125. X sub 10 will be 0.000 9765 625. X sub 11 0.000488. Okay, X sub 12 0.000 3 zeros and a 2. And the list goes on. Let me make X sub 13 will be 0.0001. Well, then I go back. 14. So if I just hit equal, this calculator allows you to do that. If you just hit equal, it's going to take that, and that is 0.4 zeros. 610. 15. So this is very slow because it's just the answer divided by 2. 4 zeros again, a 3. And if I hit 0.5. How about 16? 4 zeros. I didn't intend for the problem to be this long, but you know, 152 x to the 17. Normally these things die quickly. And here we are. 5, 7, 6. So now we're accurate to 4. And if we do 18, pretty much we're done. So this takes 18 iterations to really get the 0 accurate to the 0 of this problem, because it happened to be a 0. And if I hit it, oh, it erased. But we get the point. If I take 0.000076, and if I take the answer minus the answer divided by 2, that should do the trick. And here it is, 0. So it is accurate to 5 decimal places, and that will be 18 iterations. Again, none of the problems that I'm going to give you on a test or a quiz are going to accumulate that much. We do one more really quick. Again, to do this, x sub n plus plus 1 is x sub n minus f of x sub n divided by f prime of x sub n. I need the derivative. Well, derivative of e to the x minus 1 is just e to the x. So this will be x to the n, or answer, minus e to the x sub n minus 1 over e to the x sub n. And here we do the same thing. We say, all right, well, what's x sub 1? They told us it's going to be x sub 0 is 2. Let's get those, x sub 1, x sub 2, x sub 3. So if I take 2 and I plug that in, now that's stored in. And if I go in and I say, let's take that answer minus parentheses, the exponential raised to the answer, minus 1 divided by the exponential raised to the answer. And that's 1.135, 1.13533, 1.135335283. X sub 2 would be, so the second iteration, if I just hit back on your calculator and enter, it'll be 0.4566 496 552 x sub 3. If I just hit back and equal, I could just hit equal on my calculator, it'll work. That will be 0.0900 5186 556. Now if I was looking at this, it should be getting close to 1, because e to the x equal 1, 1x equal, no, 0. I should be getting to 0. Well, let's see. How about if I go one more? Let's see. X sub 4, I'm getting there very quickly. 0.00. Now I got it locked to 1 decimal. 393, 393,565, dot, 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 x sub 5. 6 zeros, 0.000006 or 5 zeros, 1, 2, 3, 4, 5, 7, 7. So 6 iterations, and it will agree to 5 decimal places. If I go back, and there it is. That's 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 299. So it agrees to 5 decimal places. Basically, it took 6 iterations, and that's pretty much it. That's how we do these problems. Again, it's a calculator problem, nothing more. Make sure you get the formula down, and then just using the iterations. And there's the homework.